1036 number of subarrays that match a pattern 2. And for this problem, we are giving a pattern. So for example, this is a 1, 1. And we are also giving a number of nums. So it's going to be the integer nums. It can be, yeah, it is always positive integers. Now we just need to check the three conditions. And we also need to know what is a subarray. Yeah, so the subarray must contain contiguous. So for example, 2, 3 is a subarray, and 4, 5 is a subarray. Yeah. And now let's just check those three formulas. So these three formulas basically means if the pattern is 1, this means the first number, for example, is 2, it should be less than the second number. So if the pattern is 0, this means the first number equal to the second number. So if it is a -1, this means the first number is more than the second number, 2 gonna more than 1. So this is just the basic pattern. If you understand that, basically you're gonna find an idea to solve the problem. So if we are giving a pattern and this is just nums, can we transform this nums into a pattern? So currently we have the pattern like 1, 1. If we can transform the nums into a pattern, basically we can solve the problem by using KMP algorithm. So if it is 1, 2, 3, 4, and 6, we can turn these nums into a pattern. So for example, we're gonna turn it to a S. So normally for the KMP, it's gonna be the string and the pattern, right? So if we can turn it into a string S, basically inside it's gonna be numbers of 1, 1, 1, 1, 1, according to the definition. Now we just need to use KMP to check the string matrix. So how many of them? It's gonna be in total. It's gonna be 4. So finally we're gonna return 4. Yeah. So first of all, let's just write this S. Yeah. So I'm gonna turn such kind of nums into a pattern. Yeah. So it's gonna be 1 if x more than y, else 0 if x equal to y, else -1. So for x, y in pairwise, let's just make it one line, because in Python basically we can write several lines into one line inside of the nums. Yeah. Now let's just check what is this S, and let me just return a random number, maybe 4. Yeah, let's just check if this line is right or wrong. Yeah. Now as we can see, yeah, I think we can say that it is a -1, always -1. It means I did something wrong. If x less than y, it's gonna be 1. Else, yeah, if x less than y, it's gonna be 1. It's not x more than y. Now let's just check that. In the first example, it's gonna be 1, 1, 1, 1, 1. It seems our calculation for this S string is right. Yeah, because we are going to use the string matrix, so currently I'm going to use this variable S to represent my string, and now I have a pattern. I just need to check the string matrix. Yeah. Now let me just write the KMP. First of all, I'm going to define a next array. I'm going to define this next function. So yeah, because inside I'm going to use S. I think that is okay, because this S is just inside the function. I defined it. Yeah. So now I'm gonna prepare next array, and J is gonna be -1 and -1. Yeah, you can use any other kind of method to write the next array. I think it is okay. But for me, this is I think this is the easiest way to write the next table. And for I in range length of the string, and while j more than or equal to 0, and si not equal to sj, j gonna jump to next j, and after that j gonna plus equal to 1, and next array gonna append this j. Finally we're gonna return this next array. Yeah. So currently we finished the next table, and this is string s. And next, we just need to finish the string matrix. Yeah. So we're gonna count how many different strings, subarrays. Basically, I'm gonna set a result to 0 and j equal to 0. So for I, yeah, actually let me just copy it. Yeah, let me first calculate the next table. So the next table gonna be next, and inside it gonna be inside it gonna be this pattern. So this gonna be the next table, because I'm gonna use a pattern to produce this next table. Yeah, so currently I produced the next table by using this pattern, and I also transformed the nums into this string, into this array S. Now I can use it. So for I, yeah, let me just copy it. I think I'm gonna copy this line. So for I in range this length of this array, let me put it here, maybe it's more clear. Yeah, I'm gonna check this string actually. Yeah, so if this si not equal to the pattern, so this is gonna be the pattern j. So j gonna be equal to j next to j. It's gonna jump to next to j, and j gonna plus equal to 1. And currently I'm gonna check this index j. If this index j equal to the length of the pattern, this means I've already found a result. So I'm gonna update the result, but I cannot stop it because I need to find all the cases. It is not just one. I need to find all the cases, but I cannot set z to 0. If I set z to 0, basically it is there's no intersection. But for our problem, there's going to be intersection. So for example, if we have 1 1 1 1 1, this is going to be the string array, and our pattern is 1 1. Definitely there are 4 different cases. Yeah, so this means j cannot jump to 0. Otherwise, there's only 2 different cases. Yeah. So if we use j equal to 0, what's going to happen is that, let me just run it to have a check. As you can see, it didn't work. Yeah. Our output is 2, but actually it should be 4. Yeah, because for 1, 2, 3, 4, 5, 6, it's gonna be something like the pattern gonna be 1, 1, 1, 1, 1. But our the string gonna be s equal to 1, 1, 1, 1, 1. But our pattern is just equal to 1 and 1. Definitely there are 4 different cases, but this means we cannot set z to 0 because we're gonna count all the different cases. Actually, we can use the next table, so z gonna be the next to j. So this means if we already called this one 1 and 1, and for the next one, z gonna not set to 0 because 0 we have a negative 1 for our next table, but j gonna equal to 1. Yeah, z gonna set to 1. This means for the next one here, and this z gonna be here, and we're gonna count it as another one, and then this j go back to here, and for the next I we're gonna count it, and for the next I we're gonna count it. In this way, we're gonna count all the different cases, and this is also O m plus n for the time complexity, because this m and n gonna be 10 to the power of 6. It's gonna be a really big number, so we have to use this kind of way to solve the problem. Yeah. Now, as you can see, it works. Now let me submit it. I think the only difficult part may be about this line. Z should equal to the next j from here. So normally, if there's no intersection, j gonna set to 0. Or if we are only going to count only one case, we're gonna just have a return. But currently, we're gonna count all the different cases. So this j gonna set to next j. Yeah. Now let me just submit it again. As you can see, it's really fast. Yeah, it's nearly 100% and 0.1 seconds. And the time complexity gonna be O m plus n, and this m and n gonna be 10 to the power of 6 according to this problem. Thank you for watching. See you next time.